Welcome to Math Society, where you have access to mathematics courses for free. Today, we're going to talk about two topics, and those are, first one is difference of two cubes, difference of two cubes. Second one is sum of two cubes, okay. So these are the topics that we're going to talk about today. Difference of two cubes and sum of two cubes. So far we have covered a lot of things on two special products, okay. So there's another name for these as well, special products. There are many special products like a plus b to the whole squared, meaning square of a binomial, okay. This also falls under a special product from another side, okay, I'll show you. So this is difference of two cubes, meaning a cubed minus b cubed. And this thing is actually equal to a minus b times a squared plus ab plus b squared. This is what is this equal to? And this is a product from this side. Okay, this is why it falls under special product. And I've already actually told you what special products are. I've made many videos, multiple videos onto that. If you are not familiar with them, if you're not familiar with special products, then please watch those videos. And those videos are available onto the same channel, okay, in the same playlist as this video, okay. So the links to those videos are given in the description box, or you may want to check them out onto my channel, okay. So without any further ado, let's move on to the topic. First is difference of two cubes, okay. So as you can see, this is a cubed minus b cubed. The formula is a minus b times a squared plus ab plus b squared. Second one is sum of two cubes. So you can write this as a cubed plus b cubed. So this will be equal to a plus b times a squared minus ab plus b squared. Okay. So these are the formulas that we're going to talk about today. I've talked about a lot of formulas before, like a plus b to the whole squared. These are very fundamental and very basic formulae that you actually need to be familiar with. Second one is a minus b to the whole squared. A squared minus b squared. Okay. In the same way, we have a plus b to the whole cubed, a minus b to the whole cubed. We have talked about all of them. Okay. And today we are dealing with this. Okay. After finishing those, so there are actually 2 to 4, actually 6 of them. Okay. So maybe I have forgotten 2 to 4 and 5. Okay. 6 of them I've already talked about. So one more that I forgot to write here: a squared plus b squared. Okay. So 6 of them I've already talked about, and 2 is there. Okay. So there are like 8 formulas that you need to be familiar with. So now I'm going to prove this. Okay. So if this is clear, let's move on. Okay. So to prove this, we can also prove this from this side. Okay, this side as well. And this is the most common way to prove this. You can prove this from this side because it's a product. So that's why if you do the product of this, it will get you this. Okay. You'll get this. If you do the product of this thing, you'll get this thing. Okay? You can also get from this to this, okay, by using another formula, which I'll show you. Okay, so let's go to this proof now. Okay, so I have wrapped this up. First is a cubed minus b cubed. Okay, let's deal with this. So the proof of this one. So this thing is actually equal to, you already know, a minus b. If you have noted this down, then times a squared plus ab plus b squared. So all that we have to do to prove it is multiply it. So it will be 8 times a squared plus ab plus b squared. Okay. Do it on your own if you know how to do this, because I've already taught you the multiplications. And at this stage, you should be actually familiar, because you won't get it otherwise if you're not familiar with multiplying. Now this thing will be a cubed plus a squared b plus ab squared minus a squared b minus ab squared. Okay, so all that I'm doing is I'm distributing this into this. Got a squared b, then this changed into minus because we have plus here and minus there. So minus ab squared. This will be minus b cubed. So as simple as this. Isn't it so simple? Now this and this will cancel out because you have plus here, you have minus here, so they are cancelled. This and this will cancel out. So all that you will be left with is a cubed minus b cubed, meaning this thing is same as this. This thing is equal to this. So we have proven here that this is the formula, okay? Meaning the product is equal to this. Now let's talk about how you can prove from here to there, which some of you might be wondering, okay, right now. So please pause the video and do the note of this, okay, note this down. And now I'm gonna show you another method to prove this same formula. Okay, so we can also prove this, as this is minus, we can also prove this from a minus b to the whole cubed. By using another formula, you can prove this, okay? So a minus b to the whole cubed, I've already made a video what this is equal to. This is equal to a cubed minus 3a squared b plus 3ab squared minus b cubed. So this is what is this equal to? And if we take a cubed minus b cubed together and figure out, solve for a cubed minus b cubed, figure out what this thing is equal to, we will have our formula, okay? Meaning, let's write a cubed minus b cubed here. So we're solving for a cubed minus b cubed, meaning taking all of this onto this side. So this will be a minus b to the whole cubed minus, I'm sorry, it should be plus because it's minus there. If it gets onto that side, it is plus. Plus 3a squared b, this will be minus 3ab squared. Okay, so this is what it is going to be. And now a cubed minus b cubed. So by expanding, we won't be able to do this because we are factoring this out, okay? So expansion is in the solution, okay? Leave this as it is. Take the factor of this, which will get you 3ab, because 3ab, that's the factor. You'll be left with a minus, here you're going to have b, okay? So now, if you factor this out further, as you can see, a minus b is here common, a minus b here is common. So I'm going to write a minus b here as it is. And then whatever that I'm left with, so what I'm left with, I'm going to write the big parentheses there. Okay, so a minus b came here, meaning a minus b to the whole squared will be there. Plus this thing, 3ab, okay, because a minus b has come here. If you divide it, you're going to get this 3ab. Now, the next step will be to further simplify this, and I have to get more space, so I'm going to wrap this up, okay, as I do not have much space there left. So I'm wrapping this up. So I hope you might have noted this down already, okay. So after simplifying this, a cubed minus b cubed will be equal to, what this will be equal to, a minus b times, hopefully it's coming in the camera, yes, it's coming. Now this will be, expand this one because it's factored here, okay, so solve for this by expanded. So a squared minus 2ab. So why are you expanding this? Because we already have the factor, okay? We already have this in the factorized form. If you expand this, this will write this in a simplified manner, okay? Minus 2ab plus b squared. Let's be there. Plus 3ab. Okay, so this is what this will be equal to. And I've written small bracket because I do not have parentheses inside. Okay. Now let's wipe this step now. So this thing, a cubed over a cubed minus b cubed, this will be equal to a minus b times, okay, so a squared, and you have 3ab minus 2ab, which will get you ab plus b squared. This one will be, okay, it means, there you go, boom, you have the solution now. You have proven that a cubed minus b cubed is a minus b times a squared plus ab plus b squared. Okay. So this was it for this formula. So we're done with this one. We are done with the first formula. Okay. So keep noting all of these things down, and also try to do it before me. Okay. Before I do it, even if you get just a hint. Let's move on to another formula. A cubed plus b cubed. Why plus? Because it's the addition or sum of two cubes. So this thing is equal to a plus b times a squared minus ab plus b squared. Okay, so take note of this. This is the second one. Okay. So keep taking note of all of the things that are right. Okay, and just pay attention. First of all, we're going to do from the product side to prove that this is actually a cubed plus b cubed, because these are special products. Okay, special products. They're called special products. Okay. So this will be a times a squared minus ab plus b squared plus b times a squared minus ab plus b squared. All I'm doing is distributing it, okay, to solve. Now this will be a cubed minus a squared b plus ab squared plus a squared b minus ab squared plus b cubed. This is what this is going to be, what it is going to be equal to. Okay, now a squared b and here this a squared b will cancel out because we have minus there and plus there. Now ab squared and this ab squared in the same fashion will cancel each other out, and we will have left a cubed plus b cubed, meaning indeed these are equal. This is equal to this. Okay, if we find the product of these two factors, we'll get a cubed plus b cubed. Okay, so this is proven, so note this down. And now let's move on to another method, which is using another formula, and just like previously we have done, okay, just as previous, we're going to use another formula, okay, a plus b to the whole cubed, which is equal to a cubed plus 3a squared b plus 3b squared plus b cubed. This is what it is equal to. Now, further simplifying this, what do you want to find the value of? What do you want to figure out? This 4. We want to know what a cubed plus b cubed is equal to. Okay, and in order to do that, we have to take all of those things onto this side. So this will be a plus b to the whole cubed minus 3a squared b minus 3ab squared equal to a cubed plus b cubed. Okay, so further solving this will get you a cubed plus b cubed is equal to, factor this out, so this will be a plus b to the whole cubed minus, take common whatever that is common here. So yeah, as you can see, 3ab is common between them. Okay, so 3ab is common. Okay, and I know many people who actually are taking my course from the beginning would not be, who are taking the fundamental course, okay, may not be familiar with factorization. If you are not understanding factorization thing, here, ignore those steps. You may ignore even the second, method, okay, to prove this formula, okay. So all that you need to care about is proving this from the first principle, meaning from the first method that I taught you, okay. Any person who knows how to factor this would understand this, okay. So if you know how to factor, it's fine. If you do not know how to factor, then understand what you understand, because the things that need to be understood, you already may understand, okay, except factorization and except the second method, okay. You, definitely would understand the first method, which you should care about, okay. The second method is just an alternative, okay, for an additional thing, okay. And all of this thing will be clear at the end of the fundamental algebra course. If you do this right, if you are actually working hard, do your hard work. If you take 3ab common, you'll be left with a there, and it will change into plus because you have minus in front of it. Okay, if you have minus in front of it, it changes into plus. Okay, it will be b here left. Okay, or a cubed plus b cubed. This will be equal to. Now take the common there in this whole. Okay, so the common here is a plus b. So you will be left with a plus b to the whole squared minus 3ab. This is what you are going to have. What are you going to have? Okay. Now a cubed plus b cubed will turn out to be equal to a plus b times, all I need to do, solve for this. Okay. Just like we did previously, a plus 2ab plus b squared minus 3ab. Okay, upon solving this, you'll get this thing equal to this, as you can see, a plus b times a squared, and 2ab minus 3ab will be minus ab plus b squared. Okay, so you should have already understood this, even me writing this, because it's already written, even though I'm gonna write it down. A cubed plus b cubed, this is equal to, I don't have space so I write it here, a plus b times a squared plus ab, because this minus this, 2ab minus 3ab minus ab. Okay, I did a mistake. Minus ab plus b squared. Okay, so this is what is this equal to? A minus b times a squared minus ab plus b squared. Okay, so as simple as this. And it's done now, and I'm gonna wipe this down. Okay, so pause the video if you want to note this down. And okay, so please note the things that you need to note down. Okay, and now I'm gonna mention the formulae that I taught today. Formulae. Okay, you need to memorize these formulae. First one is a cubed minus b cubed. We talked about. Okay, we've talked about. So this is equal to a minus b times a squared. Tell me. Okay, you should tell me. Okay, you keep telling me. Okay, a cubed plus b cubed. This is equal to a plus b times a squared plus there. Okay, sometimes I also make mistakes. Okay, because there are a lot of confusing signs there. Okay, I know, but I'll explain how to memorize this. Okay, because hopefully I haven't written anything wrong now. Okay, I haven't. So how do you memorize this? Okay, because there are a lot of formulas for beginners, okay, which may seem intimidating, okay, intimidating to memorize. So how do you memorize this? A cubed minus b cubed is equal to a minus b. So you have minus there, and when you have minus at the front, all of them are plus. All of them are plus, okay. So when you have minus, all of except one term, when you have minus a cubed minus b cubed, okay. When you have of minus, all the terms are plus except the first one, okay. Except the first one. In the first expression, you have minus in between. When you have plus, this is plus, but here at one place you have minus, and then this is plus. Okay, so hopefully this video was helpful to you, and you have learned something. Okay, throughout this video, throughout this lesson, and today's lesson. Okay, if you want to note this, please note this down by pausing the video. Okay. Now it's time to leave. Okay, but before leaving, the book for the course, the upcoming algebra course is this: Sullivan Algebra and Trigonometry. This is the book that I use. I use the 9th edition. If you have the 11th edition, it's actually more fine. Okay, more fine if you have the 11th edition. If you don't have the book, you still get the concepts, you still get the things, but if you don't have this book, then okay, but you need to get a book. Okay, get a book for practicing, because you cannot get mathematics without practicing it, because mathematics is a thing of practice. You'll get more if you practice more. Okay, you need to understand the concept. Okay, and when you're done with the concept, you need to practice. This is what mathematics is all about. Okay, so get any book. If possible, get this book, Sullivan Algebra and Trigonometry, because I'm teaching you this. Okay, I have the 9th edition, but if you have the 11th edition, it's more fine. Okay, and the course is coming, the algebra course. This is just the fundamental, and I'm doing from the review section of the same book. Review section. Okay, this may be 49 page. Okay, this may be 49 page of the 9th edition of this book. Okay, so flip this page if you have it. If you have this of 9th edition. Okay, I'm doing the review section. I haven't even started the first chapter, which is about equations. Okay, I will start it after doing the review section. And when you have the prerequisites built, okay, so this is why this course is algebra fundamentals. So this is it. See you in the next video.